All right, let's go now on to an example now of our cotangent function. All right, and so we're going to go ahead and graph 2 cotangent of x over 3 by hand. And because we are in the cotangent world, we always want to have our critical or our key points, which I have right there. All right, and just as we always do, we always want to set this guy right here equal to theta. All right, so I'm going to go ahead and do x over 3 equals theta, which means if I solve for x, x must be 3 theta because I multiply both sides, by 3. Okay, so if I multiply both sides by 3, I get 3 theta. All right. So let's go ahead and set up a new table. And we're going to go ahead and find our new x values. And then we're going to plot the points right here for cotangent of x over 3. All right, so the way that I'm going to find my x values is as follows. I take theta and I multiply by 3. So take theta and then multiply by 3. So 0. Pi over 4 times 3. That's 3 pi over 4. Pi over 2 times 3. That's 3 pi over 2. 3 pi over 4. So that's 9 pi over 4. And last but not least, pi times 3, which is just 3 pi. Okay. And, once again, see, the distance between 0 and 3 pi over 4 is 3 pi over 4, right? So this right here would have to be 3 pi over 4 plus another 3 pi over 4, okay, which is going to be 6 pi over 4, right? And then that's going to be a 3 pi over 2. And see how we get 3 pi over 2? And then if I add another pi over 4, I'm going to get this. So these all come from just adding some kind of constant radian, which happens to be for this one 3 pi over 4. All right, and the way that we find our y values is we take 2 and we multiply these right here by 2. So the undefined right here is going to be undefined still. Multiply that by 2, 0, -2, and undefined. Again, I multiplied all these guys by 2. And right now we have 1 period, right? And this right here is 1 period. And so the distance of 1 period is 3 pi. From 0 to 3 pi, the distance between 0 and 3 pi is just 3 pi right here. All right, so let's go ahead and graph this guy. So go across here. Maybe I'll kind of go far over here. Let me just remind you, it doesn't matter if when you make your other period, if you want to make it to the left or if you want to keep going to the right, it doesn't matter. It's the same thing. Our graph continues forever, both to the left and to the right. So you have that cool freedom. All right, so let's see. So we have a 0. We have a 3 pi over 4. 3 pi over 2. 9 pi over 4. And 3 pi. Okay, and for the sake of our problem here, we know that we want another period, so we can just continue either going to the right or we can actually just go to the left. And actually, maybe I'll just do that right there. I'll just continue here to the left and just basically duplicate these. So we'll have a -3 pi over 4, -3 pi over 2, -9 pi over 4, and -3 pi. Okay, so let's go ahead and put in our asymptotes. So we have it at 0 and 3 pi, so 0 and then a 3 pi, which then means we would have one right here at -3 pi. Okay. Next, let's plot. Let's see. So this is going to be, I guess I'll call this right here 1, and this right here will be 2. So right here will be 1, and this right here will be 2. Okay, so at 0 is going to be undefined, which we have that 3 pi over 4, 2. So 3 pi over 4, 2. 3 pi over 2, 0, and 9 pi over 4, negative 2. And the graph will look something like that. And we can transpose that over here. So that'll be 0. So go up to 2. This one will go down to negative 2 there. And there we go. So it's just a matter of graphing the first period and then just transposing this over, transposing it, connect those dudes, and we have 2 periods. Feel free to make 3 or 4 periods. And also, it's kind of neat to also graph these on your graphing utility, just to check them and see what they look like on there as well. But we could probably do a little bit more of that during class then. Okay.